All right, can everybody hear me okay? And I am now sharing my screen, it looks like.
Yes, sir.
Yep,
Joe,
we
we can hear you and see
can.
your screen.
Everybody see the welcome to Laboratory Requirements Lunch and Learn, is that correct?
Yes, sir.
Very
Yes.
good. All right. Ooh, I shouldn't have done that. I'm having to admit everybody when they join, but we will we will catch up on them shortly. Okay, I hope everybody's having a good day and getting ready for the winter wonderland that we're going to happen here in a couple of days. It looks like I'm supposed to travel to Michigan on Sunday. I'm looking to move it to Monday or to Saturday to maybe get up there before the snow.
You better get here Saturday.
Yeah, that's what I have heard. That's what it looks like. And I actually changed going through Charlotte. Now I'm going through Atlanta, and actually I'm thinking of changing and going through Minneapolis now. So
Well, the
we,
frozen tundra's already happened in Wisconsin, so
yeah. All right. Well, we will get going. This is going to be 30 minutes or so, and then we'll have some questions and answers for anybody that wants to stay on after we finish the presentation to talk about this topic or anything else. But this is basically going over laboratory requirements from ISO, from AS, from IATF, and they're all pretty much the same. About calibration, about MSA studies, about laboratories and laboratory scopes you might have to have. But a little bit about me. I work for UT Center for Industrial Services as a consultant, and I also am an auditor for a couple of different registrars doing IATF 16949 audits. I'm also trained as a ISO 9001 AS and the environmental and the medical device as a lead auditor as well. I'm actually involved in ASQ, and again, I consult with companies doing gap assessments, certification helps, and through UT we provide this service for free once a month or so. I try to do a topic and go over it with companies within Tennessee and outside of Tennessee too. And I think on this call is probably the biggest one I've had. I'm supposed to have 65 on this call, which is great. Okay, so let's get into requirements. And IATF says you got to have a lab scope. That includes the capability of performing any testing, inspections, or calibration. When you're defining your lab scope, you need to question what inspections, what tests, and what calibrations we do within the lab. And all of these must be included in your lab scope. Most companies or many companies just put we calibrate these types of gauges. That's one of the three things called out in the IATF standard. You also need to consider what inspections you might do in the laboratory and what testing you can do, be it pull tests or destructive testing or any kind of testing, from lengths of parts on your CMMs to, if you have a paint thickness gauge, you check paint thickness. That needs to be included in the lab scope. Also, the lab scope must include the adequacy of the technical procedures. What procedures you use to do the testing or the calibration that you do, what testing you can do, any customer requirements. If the customer says you got to test parts, for paint thickness using an ASTM spec, well, then you need to reference that ASTM spec within your lab scope. You also should include any required customer procedures. If they say to test per, Ford's WSS 16949, whatever it may be, you need to reference that within the lab scope as well. External labs. If we use any external labs for anything, for testing, for calibration, these labs need to be 17025 or equivalent. There is some sanction interpretations that's came out on this requirement in the IATF standard, and they did say you can use a 17025 or a national equivalent. and you got to have the certification mark of the body on the certificate or the test report. There's a big or that came out. And this or is very important for anybody in the laboratory or using outside labs to understand. When you use a non-accredited lab, meaning they're not A2LA, they're not 17025, that's okay. But your organization needs to document, show evidence that you're okay with them and that they meet the requirements of IATF 7 clause 71531, which is you got to have an internal lab scope. So you got to have a copy of their lab scope, and that lab scope needs to include what testing or calibration service that they're providing. Where companies will get in trouble is if they're using a calibration company to calibrate a weight scale, a balance or a scale, and it's okay to use a non-accredited lab or service, but you need to have their lab scope. And if their lab scope don't include calibration of balances or scales, then you're in violation of this requirement, the standard. And that's what this says. You got to have an internal lab scope for whatever the service is that they're providing, balance calibration, thermocouple calibration, whatever it may be. This is what's required if you're using an outside company. You're supposed to have the stamp of accreditation, the A2LA certificate or the MLA label or the 17025 label. It needs to be on the certificate. Why might some calibration companies resist putting this stamp of accreditation on their certificates? Anybody have any idea why they might not do that sometimes?
No,
What's that?
no.
Yeah,
Why?
sometimes they don't do that. But why might an external lab not put the stamp on the certificate? Anybody had that experience?
Sometimes
Joe, would it be
they
because
charge extra for it? Like it's an extra service that it's part that they're accredited to. And so if it's on their accreditation scope.
It is. That's the main reason that some labs don't put it on, is because they want to charge you an extra $300 or $500 for that stamp. And it's kind of a racket. But it is the requirement of the standard. But if you don't get that stamp on the certificate, you should at least have a copy of their lab scope that includes that service that they're providing. In this case, they were calibrating a CMM. So they would need to have that on their scope of their lab scope. What gauges or measurement equipment needs to be calibrated? And I see this a lot in companies where a company will have reference only on gauges, reference only. And I always say, well, go to the standard. What does the standard say? And ISO is very clear. And this is a simple ISO requirement. When a measurement traceability is a requirement or considered by the organization as an essential part of being confident in the measurement and the measurement results, that equipment, meaning that gauge, needs to be calibrated. And it really, you have a hard time convincing me that any gauge you have on the floor that we're using to check parts, if it's marked reference only, why is it there? Do you not need to have confidence in that measurement? And honestly, I would recommend that if you have reference only gauges, you really need to think about what are you using that gauge for, and do you need to have confidence in that measurement? And if you need to have confidence in the measurement, sure, that needs to be calibrated.
How about situations where you know that another measurement is being done with a calibrated gauge further down the line? So it's, like a spot check or something.
But again, I would question that do you need to have confidence in whatever it is, the first gauge that you're using? Why are you doing it?
Yeah,
And
because you might scrap something that shouldn't have been scrapped in a case like that. I guess.
yeah, you could, but I would question it. But that's a good discussion to have. But you need to. Again, I would go back to, do you need to have confidence in that measurement, whatever it is that you're doing? Mhm. Okay. What do we do if a gauge is found to be out of calibration? You know, sometimes we find gauges that are out of calibration when we're calibrating them. The as received condition is out. And the standard's pretty clear, both ISO and IATF, and has requirements. And ISO simply says you got to determine the validity of previous measurement results that may be adversely affected when it's found to be unfit. And you need to take appropriate actions. That's all ISO says. So when you have a result that is invalid or out of calibration, you need to take appropriate actions. IATF says you got to do an assessment of the risk of intended use of the product caused by the out of spec condition. And IATF also says when a piece of equipment's found to be out of calibration, you got to document the validity of previous measurement results, and you got to keep a record of this. One question I always ask, because I see this problem more on externally calibrated gauges than I do internally calibrated gauges, but I question who reviews calibration records when an outside company, an outside lab, performs calibration. And believe it or not, in a lot of companies, those reports are just sent to purchasing or sent to the calibration lab, and they file them in the filing cabinet, and nobody looks at them because the calibration company, all they're responsible for is calibrating the gauge, and they're going to calibrate it, and they're going to give you a report. One area where I see lots of findings in calibration related to external labs is if all the lab records or all the calibration records don't go through the lab, then there's a risk for failure there. And I do see that when, let's say, the purchasing group organizes and gets the calibration companies to come in, and they get the records and they keep the records, and it don't go into the per se calibration system or the laboratory. That's a recipe for disaster. I recommend all calibration records and reports go through the lab or go through your centralized calibration system. But here's an example of a outside lab report that comes back, and this is of a CMM, and the as found was fail. Somebody needs to identify this. The calibration company may identify this when they're here and say, hey, you know, the as is was out and we've calibrated it. But typically they don't. They just give you the report. But somebody needs to look at the report and flag this report and say, hey, it failed. And what do you do when you have a failed as received calibration? You have to go back to where we were here. And what does it say you do? You got to do a risk assessment. Both in ISO and IATF says you got to investigate it. And you need to do a risk assessment. It must be maintained. It could be in the form of a calibration record within Gauge Track or Gauge Pack that you make a note in there what the risk assessment was. It could be handwritten on the calibration report. It could be on a separate form that maybe you use when gauges are found to be out of tolerance. You always use this form. I recommend that is the way you go because it's a standardized process. But that record should include, you know, what was out of tolerance when this gauge was found to be out of tolerance. How far was it out of tolerance? What's the gauge used for? What's the tolerance of the characteristic being checked? And have we determined what risks they are? You know, you may determine that the gauge was out a very little bit and our spec is wide open and there is no risk. That's fine. You document that, hey, it was out this much and our tolerance is this, there is no risk. You document that and that's your record. Or it could be that it was out a lot and you got to go back and contain parts and you got to contact the customer if that's applicable. ISO says you got to calibrate gauges against a measurement standard that's traceable to some kind of international or a national standard. Other common calibration errors, not recording the master used. And the master must be traceable to a national or an international standard. In the US, it's typically to NIST, the National Institutes of Standard and Technology. An example, if you're using a micrometer to calibrate a go, no-go gauge, and it's okay to do that, the master used might be the micrometer number XYZ123, and you should have a calibration record for that micrometer that's traceable to NIST. And the calibration record of the go, no-go gauge needs to reference that you used this micrometer. This was the master that was used. If you don't reference that, you've lost the link to your NIST traceability. And that's a common error in calibration records. You always must include the traceability of the master used, and that master needs to be traceable to NIST. Gauges and calibration equipment needs to be safeguarded, needs to be protected from damage or deterioration that would invalidate the measurement results. Common errors in this is gauge covers being broken, or the lenses being broken, or the gauges being filthy and nasty and not protected or not in the right environment, causing potentially erroneous readings. And really, anytime you have a calibration finding, there's a high risk that could be classified as a major nonconformance in your audit, if, in the opinion of the auditor, that calibration could potentially result in non-conforming product or non-conforming product being shipped to the customer. AS 9100, very similar requirements. They just say you got to maintain a process for recall of monitoring and measuring equipment. And basically that's your gauge list, your list of gauges that you have in GaugeTrack or GaugePack or whatever the software that you use. And you don't have to use a software, but I have had companies last year in my audits that they lost their GaugeTrack or GaugePack. It crashed on them. I actually had 2 clients that this happened on, and they tried to limp along with an Excel file. And it didn't go well for those companies, because if that might work if you have 20 gauges in your plant, but if you have thousands of gauges, which a lot of companies do, keeping up with that on an Excel file is almost impossible. So I would recommend, unless you have a very small plant, have a system, a GaugeTrack, GaugePack, or you can do it in Plex now. Have some system, but AS requires you to have some system. AS says you got to have a register on monitoring and measuring equipment. Statistical studies, and IATF's the only one that requires that to have statistical studies on your measuring equipment, but you should do that in regards to if you're not IATF, you're just any company. But statistical studies done to analyze how much variation is in the inspection, measure, and test equipment, and to see if that it is appropriate for what you're doing, for the gauging that you're doing. All types of inspection and measure and test equipment called out on the control plan needs to have an MSA study done. Typically, we call those gauge R&R studies. That includes gauges. That includes camera inspection systems you may have. That includes visual inspection processes if somebody's visually looking at gauges. That also includes your poke-yoke systems, your error proofing systems you may have in place. Look at your control plan. Those gauge systems, those measurement inspection systems on the control plan, they need to have an MSA study completed. When do they need to be completed? Maybe after you make an improvement in an inspection process. When there's a change in the inspection process, maybe you used to use weld penetration checks was done manually on a microscope. But if we upgrade to a PACSIT system that automatically measures the weld penetration, that's a different system. You need to prove out that system. You do it whenever the customer requires it. Some customers might require that annually, but there is no requirement in any standard that says you got to do it at certain frequency. They just have to be done. Basic rules of MSA studies, they need to be less than 10%. If they're on variable gauge R&Rs, meaning you got a number that you're addressing. 10 to 30% is considered marginal, depending on the use of the gauge, the risks. Greater than 30% is not acceptable. And the number of NDCs, which is number of distinct categories or buckets that your samples come from, needs to be 5 or greater. If your NDCs is less than 5, your study's invalid. It's not considered acceptable. Basic rules for attribute studies is basically the kappa value. The kappa value's got to be greater than 0.75. What do you do if your gauge R&R is not below 10%? Well, per the MSA manual and common sense is that you should investigate, identify where the variation is coming from, and you eliminate that variation and redo the study. And if you cannot improve the gauge R&R to an acceptable level, then you, the organization, and or your customer needs to justify using the gauge. When I'm investigating a high gauge R&R, I always look at the R-bar charts primarily. If a point is out on the R-bar charts, you investigate the data. You look at the raw data and see what happened. And sometimes it's a typo. Sometimes somebody fat-fingered something. Or it could be that an operator's doing it his way, that he's just his range is much higher, or maybe his individual value, it averages much higher than somebody else's. They may be doing it differently, and you might need to improve the process of how you're gauging, because sometimes operators just do it their way. They want to do it their way, and that introduces variation to the process. Not using the normal employees that use the gauge as appraisers. It shouldn't be just the quality manager and a supervisor and the plant manager doing it because they're the only ones that have time. It should be done with the normal people that use the gauge day in and day out. Other errors is not justifying or investigating when your gauge R&R is above 10%. NDC's got to be greater than 5. MSA study, again, is invalid. There's not enough variation in the samples if the NDCs is less than 5. And that is one of the hardest parts about doing a gauge R&R study is getting the right samples. You can't really just go out and grab 10 samples out of production and say, this is the samples we're going to use, because most companies don't have that much variation in their normal production process. So you need to get with production and say, hey, I need some parts on the high side, some parts on the low side, maybe some parts out of spec. You don't want to risk getting non-conform product to the customer, but sometimes it's good to have a part out of spec for a gauge R&R, and that will increase your number of NDCs. Maybe the inspection process is not clearly defined. Operators are doing it their way, not clearly defined where to check on the part. And this is critical if your parts can have variation. And my company in the past, we made steel balls for bearings. And one of the things we learned when we started doing MSA studies was when we checked surface roughness, we used a surface roughness tester to check surface roughness on a steel ball. We learned that, hey, we had to mark each part to to get more consistent readings because there's variation on different areas of the ball. So we mark the parts where to check. And then we learned that, hey, they actually need to be checking in the same direction. So we actually mark on the part a rectangle, and then we marked on the part, you check it in this direction. And that alleviated a lot of noise and variation that we had in the study. Other mistakes, you need to refer to your customer specific requirements. Some customers may require that you do a gauge R&R study a specific way. Maybe use the ANOVA method, or maybe require you use a certain number of samples on the high side and the low side. Some may require doing an annual MSA studies, but that's up to your customers. I always recommend save your gauge R&R parts. You know, if you need to redo a study in the future, it's best to use the same parts that you did the previous study, especially if you're making improvements and you want to compare your new study to your old study. It's best to have the same exact parts to prove that you have actually made an improvement to the inspection process. Sometimes the gauge or the gauge process is not robust. The gauge should be calibrated before doing any MSA study. IATF has a requirement in air proofing that challenge parts, your poke yoke masters, they need to be controlled, verified, and calibrated where feasible. And sometimes when you have a poke yoke master that is not calibratable, meaning maybe you have a master that has a missing nut on it that's going through your inspection process. Well, you can't really calibrate that, but you can verify that gauge at some frequency to make sure it is missing the nut and that it's working and functioning the way it's supposed to when they run it on their inspection process. And those should be in your calibration system, your GaugeTrack, GaugePack software. Other training opportunities that we offer at UT, we have an internal auditor, ISO internal auditor class coming up in Blountville, Tennessee in April. We are going to plan on a remote ISO 9001 class and a remote IATF class in the near future, and I'll send out some information on that. There's been nothing new posted in regards to the release of the new ISO and the new IATF standards, and the new AS standard will come after that. Other than it will be in Q4 of this year will be ISO 9001, and about 3 months after that, the other standards will follow: the AS 9100, the ISO 14001, and IATF. And those of you that are internal auditor trained right now, you don't necessarily need to go to a new internal auditor class, but you should go to a class or get competent somehow regards to the changes to the standard. And we're going to be offering a class to those when they come out, either a half-a-day class or a one-day class on the changes to the ISO and the IATF and the AS requirements as well. We do have a YouTube channel that I'm going to click on this and see if we can get it to pull up. That includes past lunch and learns that I have done. And some of these may be beneficial for your organization, such as we did a simplified problem solving lunch and learn. We did one on internal auditor best practices. We did one on the rules changes to IATF. We did one on how to complete your JSON file if you are an IATF company. And these are free and available for anybody to use. And if you just Google or go to YouTube and look at University of Tennessee Center for Industrial Services and subscribe to it anytime there's something new posted, it's available for you. And let me minimize that and go back to this. Any questions or comments for me?
I have a comment and a question.
Sure.
First, I really appreciate you doing these lunch and learns. This is one that's probably, I think it's in our top 3 for nonconformances in general, as measurement systems and laboratory. I know as you were describing some of the examples, we've had We've had cases with nonconformances where the as found on a CMM is, out of tolerance, et cetera. So I think this is really on topic. But a specific question, we just recently had a surveillance audit, and the laboratory scope didn't include a test that had just been done for the very first time. It was this is a lab that can do, say, 15 different tests. And then this was a specific request from one of the plants. It wasn't on the scope yet, but they did it. Do you think the new test would need to be added to the scope before the test is done, or can that be the thing that kicks it off to get onto the scope?
It's bad timing. I'll just say that.
Yeah.
you had bad timing. The rules are it needs to be in the scope, but I'm a realistic auditor myself. I hope I didn't write that up.
Nope.
But I would be realistic that, hey, it's new and they just we haven't gotten around to adding it to it. But there should be some kind of process that you have when you do introduce a new gauge or a new inspection testing method into your lab, that you update your lab scope. So there should be some kind of review done to ensure that. And maybe that's part in your internal audit process as well.
Right. And it does make for a fairly straightforward corrective action, because that's exactly what we'll introduce a system where, it has to be, and plus that way the method can be described and laid out if there's a ESTM method or something like that.
Right. Mm-hmm.
Okay. Thank you.
Any other questions, comments? Anybody have any other topics they want to do, would like to see at the next Lunch and Learn?
Hey, Joe, I had a question.
Sure.
So for the lab scope, I know you said it's for the lab. Does that count for your entire plant? So if you do plug gauge checks on the line and not in your lab, would that have to be included on your scope? That's
an interesting question, and that's the one that I really don't have an answer for. I know the way I interpret it is everything within your lab, what you do in that lab. So again, that's my interpretation. I know you might do different testing out in production that you don't necessarily do in your lab. That's one of those that's not clear what needs to be in that lab scope. So that's not a good answer, but I think that's the answer that I have.
If you were controlling your calibration of those devices out in the plant through your lab, you'd need them on there though, right?
For the calibration portion, yes.
Right. Okay.
Mm-hmm. Any other questions, comments?
Question for you, Joe.
Mm-hmm.
About doing MSA studies on measurement systems where there may not be a total of 3 or more operators trained in it. Let's say you have some specialized equipment where maybe only 1 or 2 members are trained to use it. How would you handle a situation like that?
I would document it and note in your MSA study or your gauge R&R that you only have 2 people, and that's what we did. And we did a 2x3x10 instead of the normal 3x3x10, and justify it. Yeah.
Thank you.
One other thing that I meant to put in this that I didn't was in regards to gauging is the 10-to-1 rule. Meaning you got to have 10 increments within the range that you are inspecting. For instance, if you're measuring the weight of something and your tolerance is plus or minus 1 gram, the gauge needs to be reading in at least 0.1 gram increments. You got to at least have 10 buckets. The 10-to-1 rule within the measurement system, and I have seen that error specifically on scales, weigh scales. Any other questions?
Good afternoon, Joe. It's Jeff Simpson.
Yeah, Jeff.
How are you today?
Very good.
Good. Question. I've got my CMM guys and calibration guy in this meeting with me. Very good topic for them. But as far as the gauge R&Rs or the MSA studies, normally we do that by family. Is that still acceptable rule or?
Oh yes, that is the rule, and I should have emphasized that, but I didn't. Yeah, MSA studies don't need to be done on each gauge, but they do need to be done on each gauge type. So for instance, and this is one that got a company in trouble last year with me, was they used a calipers in the plant. Well, calipers can be used for many things. You can measure OD with a caliper. You can measure ID with the other tips, and you can also measure the depth of something with the depth portion. And if you're using it for those three things, you really need to have three separate MSA studies because it's three different gauges in one. But yeah, it is for gauge types, gauge families. That's what's required in the IETF world. Any gauge type or gauge family. So if you do visual inspection, and this is another one that's kind of gray, but if you do visual inspection on parts, you need to do an MSA study on visual inspection. But if you're doing visual inspection to check for scuffs and you're doing visual inspection to check for this or that, I would pick the most critical thing you're checking and then say that's the one I'm going to do related to visual inspection.
Thanks, Joe.
Mm-hmm. Any other questions?
Another one talking about attribute studies. We recently completed one here at our location, and I think the first time we did one, we realized that we had been looking at too much of the entire product. We needed to kind of scale it down to a smaller area, kind of like you suggested with the steel balls. But I was wondering, how many samples do you recommend for an attribute agreement analysis?
Typically, it's 50 parts, 25 good, 25 bad. But that can vary in your customer specific requirements. I know GM or Ford, one of those has kind of a wonky way they want you to do the MSA study. They want certain many in, certain many out, certain many right on the limit. Yeah.
Our customer specific requirements didn't have a number there for us, but what we were running into difficulty was the overall size of the part and being able to get that many unique pieces and storing them and being able to manage that for the duration of the study.
And that's something to consider. And if you did less than, I would say 50, justify why you did, size and shape.
Okay, so just document
why you did what you did. Yeah.
Okay, thank you, Joe.
Mm-hmm.
And sometimes you can't keep the samples because they're consumed in the testing. So
yes,
that's something to consider too.
Yeah, sometimes or the space, you just can't keep great big parts laying around. But if you can, it is best to reuse them when you have to do another MSA study down the road. Anybody else? No other questions about MSAs or calibration or really anything? Anybody got any other questions? This is your time for me to answer questions.
Hi, Joe.
I'm gonna mute you until you fix that. There we go. Yeah. I think you need to turn off some mic or got something going on. But Drew, if you want to unmute after you correct that, we'll answer anything you got.
Hi, Joe. This is Mike Chernobyov.
Yeah, Mike.
Hey, I have a question like on the 310 study. Say you use 3 operators for that test, and then like let's say it was last year and 2 of those people have left. do we need to do a full cycle MSA study for new operators? What would be the typical timeline for that
Well,
you would see?
well, typically you do MSA studies for the process, the visual inspection process. If you have new people coming in to that process, one good way to qualify them is to do an MSA study on them. That's how we used to qualify our visual inspection ladies that inspected balls under the microscope. We do an MSA study on them. We do a compare it against our good known inspectors, but that's not a requirement that you have to do an MSA study on every new inspector that comes in the door. That's not a requirement, but not a bad idea. Or at least qualify them somehow, have some kind of a test for them to do. This is a test for them to do is the MSA study. I hope, did that halfway answer you?
Yes, it did. Thank you.
Okay. Because I have seen other auditors write up companies for not redoing an MSA study when you have a new visual inspector, and I don't see that requirement, but I have seen that wrote up.
I have a question. Is a verification considered a calibration of a gauge?
What was that, Alejandro? What was
Is
that?
is a verification of a gauge considered a calibration, or they are different things totally?
Well, you can verify a gauge or you can calibrate a gauge. You can, just like an example might be your micrometer. You might calibrate your gauge every year with a known set of Joe blocks or something like that. And you might verify it daily with a block itself. You might verify it daily. Verification could be like on an error proofing device. Like I said, the Red Rabbits, you might verify those and not necessarily calibrate them, but you verify that it's still functioning appropriately. One thing, like on a hardness tester, anybody that's experienced with hardness testing, the ASTM spec, I think it's E8 or E18, it requires that you validate the hardness tester every day that you use it. You got to use a test block and you validate those test blocks. You test it twice to make sure it's reading within the range on that test block. That's verification. Calibrating is something else. That's a more in-depth activity that's done on a hardness tester.
Okay, got it. Okay, thank you.
Any other questions? Comments? Well, this video will be uploaded onto that YouTube channel. If somebody in your organization missed it, they can review it at any time.
Good. Very good.
Okay, thank you, Joe.
Thank you.
Thank you, Joe.
Thank you.
All right. Well, everybody have a wonderful day and stay warm in this blizzard that we're getting ready to have, and safe travels.
You as well.
Thank you.
as well.